Good day, ladies and gentlemen. Welcome to the OffGridEnclave channel. Heating is a significant part of survival if you live anywhere with a proper winter. Today we will be looking at my redundant heating system that keeps the Happy Bunker project warm. My system consists of two different heat sources. In the future there will be a third added, more on that later in the video. On the left side in black you can see a pretty standard wood stove with a water transfer tank. On the right side in red is a more modern computer-controlled heating with a material tank that will run on wood, pellets or coal. We will begin by having a look at the simple wood heating. This heating can produce about 29 kilowatts of heat. 23 kilowatts of that can be transferred to water, the rest heats the surrounding area and air. It has a big but pretty standard burning chamber, nothing special to see here. The interesting part is the upper section of the device. Here, the hot gases pass over multiple layers of a tank and heat the water inside. The main benefit of this heating is that it has very low power requirements. 25 watts for a water pump is enough to run the system. Having a look at the other, more modern system, you can see it has a control panel to inspect stats and configure a lot of the parameters. The lower of the two burning chambers is where the material for burning gets transported by the transfer screw. This is where pellets, wooden shrapnel or coal gets burned. Above that we have the big burning chamber for wooden logs or coal briquettes. This is sized enough to use wooden logs with up to 40 centimeters diameter and 50 centimeters in length. On the top, just like with the other heating, is the water transfer tank. As this device is much better isolated, the heat loss to the surrounding air is minimal. This heating can transfer 25 kilowatts of heat into the water and loses only about 1 kilowatt to the surrounding air. Here on the right side is the tank for the burning materials like pellets or coal. Using pellets, this tank will last for about 6 days of continuous running. Of course, this depends on the parameters like the desired output temperature. On the bottom of the tank you can see the motor for the transfer screw. This is the part that requires most power when it is running. The material will get transported through a pipe into the lowest burning chamber. This black box you see is the fan that manages the burning intensity. Up next we shall see how the heating system is used to also produce warm drinking water. I'm using a 400 liter boiler with a heat exchanger to transfer the energy. This lower valve is the input from the heating. The 400 liter tank also doubles down as thermal mass to store heat. Up there we have the backflow of the heat exchanger. It is possible to use electricity to heat the water in the boiler, but I have never used that. Down on the floor you can see a counterflow heat exchanger. This will be used for the compost heating project. The empty wall space is where the setup to combine the compost heating with the existing system will be installed. Now that we have the heating side covered, let's have a look at the basic diagram of the system. Keep in mind that this is only a rudimentary look. There is more components built into the system, like pressure bulbs, valves for controlling areas, temperature gauges and such. If you have questions, input or ideas around off-grid topics, check out our website offgridenclave.com and or join our Discord community where you will find plenty of experienced off-gridders. If you enjoyed this content, leave a like or subscribe for future videos. The two main heat sources are set up parallel. The system is designed with the idea in mind that only one of the main heat sources will run at any time, never both. The integration of the compost heating into the system, however, will be in series. As you can see in the diagram, the compost heating will be installed in the backflow of the current system. This gives the option to run any of the two main heat sources should the compost heating not provide enough temperature. That concludes this video. Wish you all a great day and make it count.